That's weird. It's giving me the same problem, even on mine. Let's see here.
Now, when I go in and look at it says live. I go and look at the YouTube channel, even though I've turned.
Yeah, I see that. Let me see this. That's because I hit started. Well, okay, it looks like it's working on YouTube, so let's just get started here. When you do a refresh, you can actually see it. Okay, hey everyone. Welcome to another. Welcome to our first fall series talks for Atlanta Functional Programming. I'm your host, Ram Badam, with the Atlanta Functional Programming meetup. Today, our speaker is Judd Taylor, who is fellow co-organizer of the Atlanta Functional Programming meetup. He will be giving a talk on Hyer, a programming language that compiles to the Python VM. Judd, for those of you who don't know, is a hobby programmer of many years. He actually was also an entrepreneur, did stuff professionally in the IT industry. His credentials are numerous. I don't think I can really do them all justice. Some of the stuff that he kind of has worked for is he worked for Coca-Cola Japan, has done stuff for templating systems, actually did translator stuff for EBCDIC and Unicode, and various other projects over his illustrious career. Additionally, he has been an active member of the Freeside hackerspace in Atlanta. So for those of you who are interested in Freeside, you could probably look him up too as well. And he currently has done quite a bit of work through the Lambda School. And if folks are interested in hearing about that, you can talk to Judd offline. Without further ado, I will hand it over to them. Folks who are currently watching the YouTube stream, just a reminder, post your talk. I think there is no way of. It looks like there's a way of doing some talks on YouTube. If you guys can post questions on YouTube, that would be great in the live chat. Also, for folks who are going to watch this later, go ahead and post your questions also in the YouTube comments, and we will definitely get back to them as time permits us. So without further ado, Judd, take it away.
Okay. Hello, everyone. I'm Judd Taylor. I'm in Atlanta, and I'm presenting this because I like Lisp a lot, and I've used Python quite a bit recently. So, WhyHy. Okay, this presentation is going to talk about Hyer and give some small examples of its use. We'll talk about what is Hyer, why might coders want to use Hyer, and very generally, how does Hyer work? And then we'll do a rapid walkthrough of some basics. Okay, so Hyer is a Lisp that compiles over to Python's abstract syntax tree. In fact, it goes to a Hyer syntax tree and then over to Python's abstract syntax tree. And from that code, Python can interpret and compile normally, because Python itself compiles human Python to Python's AST, and then can compile that or run that itself. So once Hyer gets it over to Python's abstract syntax tree, it's really hard to tell it apart from Python AST that came from Python or Python AST that came from Hyer, okay, which is a cool trick. Okay, so why might anyone use Hyer? First, Lispers might use it because there's a lot of ecosystem that's available in Python, but not necessarily in Lisp. Of course, Lisp has a lot of ecosystem of its own, but there's a lot right now, particularly in machine learning, that is available very easily from Python, but not from Lisp. So using Hyer is a good way if you like thinking in Lisp, but you want to use some things that are available easily in Python to do that. And some of the examples of that are NumPy, scikit-learn, Keras, which is a layer over TensorFlow, TensorFlow itself, Flask, which is an application framework or meta framework. And then if you're a Pythonista, then you might like using a Python code base that you're familiar with, and then trying to learn Lisp idioms by porting Python code over to Hyer. That's pretty cool. Hyer can be used to extend the syntax of normal Python, and since Hyer compiles down to AST code, Python's AST code, it does work. And in particular, Hyer does have def macro, so it can be used in the ways that def macro can famously be used in Lisp, which is all the way from just boilerplate, so that you can encapsulate boilerplate Python code or Lisp code, and then all the way up to really def macro is Lisp code building Lisp code. So, all right. So an overview of what Hyer does. Hyer, it reads in code written in a Lispy syntax contained in files that are called foo.hyer. Then it tokenizes it into a Hyer AST, and then transforms that AST into an equivalent Python syntax tree. And then that that AST can be interpreted or compiled into Python bytecode, right? So once it gets over to Python's AST, again, it's hard to tell where it came. You can tell if you look at the code, because the naming conventions for variables can be different. The naming conventions for the variables generated by the AST generator are a little different, but everything works hunky-dory. So Hyer code can make use of Python modules and evaluate Pythonic code. So you could put Python code inside a Hyer file, right? And then by including Hyer in a Python file or in your Python code or project, then Python can make use of Hyer modules using the normal Python include syntax. And Python code can, once you have included Hyer or imported Hyer, you can evaluate Hyer code inside your Python code. So the really huge thing is this is fully round trip, right? So you can write code in Hyer and call it from Python, and you can write code in Python and call it from Hyer, and you can actually put code, if you feel like it, into either. You can put the other one in the other one as code. Okay, so how do I use it? The first thing to do is to get it, and it's very easy. So if you're a Pythonista, then you're probably familiar with pipenv. So the thing to do is to make a directory called myHy, wherever you feel like it. And then, of course, change into that directory, then run pipenv shell. And then from the pipenv shell, run install Hyer, right? And now you have it. Very, very easy. So to use a REPL, you can just type Hyer. So if you can see my screen, just run Hyer, and there we go. So I'm running Hyer 0.119 using CPython on my Linux. So now, one note is that by default, representations that come back from evaluation in Hyer get shown a little differently than in Python style. But if you want to take a look, if you want to see your feedback at Hyer's REPL in Python format, then you can run Hyer REPL output function equals Hyer contrib Hyer, blah, blah, blah. You can just take this, and then you will get the Pythonic representation of something. And here's an example. At the Hyer prompt, if I type in bracket 1 space 2 space 3 bracket, the REPL will give me back basically the same thing, but you'll notice that that doesn't have any commas in it, right? So that's the Lispy way of making a list. So I have it set up to give me back Pythonic.
Question.
I guess I should change.
What is the type of that? Is that actually a Python list, or is that like an array? Could you do? Is there a type function for High so you can introspect your types?
Let's see. Of course, I'm typing Python into. Okay, set. What do I do? Set v 2 1 2 3.
Nice. Okay. All right. So you're using the full blown Python data structures. One additional question. Sorry, if you're probably going to get to this later, but for the native data structures like sets and stuff like that, how would you use those in High? Do you know? Like if you want to create like a set.
I will be getting to that.
Okay, cool. Thanks.
Now, one point is it's not exactly a Python list. It is some mildly different Python object. Certainly not a singly linked list like Lisp would want to do, right? But the important thing is that the syntax is Lispy, and it ports over to Python AST.
All right.
Right.
Cool.
So why did I did not expect to get the Pythonic representation? Oh, wait a minute. Let me try this. I can do this because this is actually my computer. You're looking at it. I'm doing it. All right. Oh. So now, one thing that's okay. So if you noticed earlier, I typed in 1, 2, 3, and it gave me back the Pythonic, right, with commas in there. See this? So if I tell it I want the output function to be high representation, then it comes back in high representation, right? But again, this is only a representation made by the REPL to us puny humans, right? Okay, so we can run through some very simple examples. So hola amigos in Python would be this, right? And then let me see if my macro works. I want to, it's very similar, right? Not very different, so cool, it worked. All right, so if I do print hola amigos, it comes back. Okay, that's very simple. So binding, what do we do here? This is how it's done. You saw me do set v earlier. That's like set f in Common Lisp. So if I do that, then now I can say what's foo. It gives me back 17. Then there's a different, there's a different way to define functions. So here we go. In Python, we would
well before you do that,
this way.
So quick question before you go into that. Just a quick question for the arithmetic operators. Do they follow the same Lisp kind of like syntax where they could take any number of arguments and then return? Like, could you do like +1, 2, 3? Yeah. Ah, nice. Okay, great. All right.
So in Python, if I want to define a function, that's the basic pattern, right? Define our def, foo, list of parameters, colon, and then what you want to do, and then eventually return. In High, it's very Lispy, and it's exactly this. So, okay, hold on. So if I say, okay, in this, you'll notice that it's defn, or define function. Give it the symbol name, or the symbol, then the list of parameters. So this is kind of clojure-y, right? It it wants a vector of parameter values. So it uses a square bracket, right, rather than classic common Lisp parentheses. And then you tell it what to do. And of course, well, we can do progging if we feel like it. So now if I call boo, oh my gosh, right? So now how to write in Python if I wanted one parameter x, so I want to say, oh my gosh, a number of times, I would define it this way. Def many boos, x is the number of times to do it. So for x in range x, run boo, right? The same thing in Hyer is this, many boos. So if I say
So just a quick thing. Your many boos in Python, I think that's invalid syntax. I don't think you can have hyphens in Python function names. You can have underscores, but I don't think you can have hyphens because
you're probably right.
Yeah.
I'll have to put that up to all right, whatever. All right,
that's right.
Caps lock on. Many boos. You're right. That would get interpreted as minus and would confuse Python. Thank you, Ron.
No problem. Just letting you. I was looking at it. I was like, that does not look right.
No problem at all. Okay, so now for a little interlude, we'll talk about the different. Why am I getting these? Okay. Here is what? All right. Full H. What one? I don't want to do that. Why can't I back out? What did you do, Ron?
I did nothing, I swear. I did nothing. Why are you trying to... it looks like you're trying to quit Emacs. Why are you trying to quit Emacs?
I didn't want to. It wouldn't let me alone. All right, so here are the built-in data types. Right, they're very similar. Nothing real strange here. Ints are the same. Floats look the same. Complex looks the same. Booleans look the same. None type. So none type in Python is none, and is also none in Hyer. So that would be null or nil in Common Lisp. Strings. This is one difference. Hyer for strings does use double quotes, right? So Python single quotes will work, and in Hyer we want to use double quotes for strings. You want bytes, same thing, similar, right? Tuples, okay, in Python, their coordinates in a tuple are separated by commas. In Hyer, we specify that this is going to be a tuple, and then we specify the coordinates inside the tuple.
Before you continue,
List,
I just want to...
a little bit earlier.
Sorry, before you continue, I just want to make a small comment for folks who are looking at this single quote versus double quote thing. The reason why Hyer more than likely is not allowing single quote for strings is because quote is an actual operator in Hyer, if I'm not mistaken, just like any other Lisp. It's the quote operator. It means that this value is not going to be evaluated at the REPL. Just want to clarify that for folks who aren't familiar with that.
Okay.
Yeah, sorry about that.
All right, so no problem. Thank you. So we're at lists, and again, we saw this earlier in syntax in Python is to separate elements in a list by commas. In Lisp, we view that space is enough separation. So that's how Hyer handles it. Sets. Okay, you asked about sets earlier. In Python, it's just with curly braces. In Hyer, it's sharp sign, followed by curly braces.
Nice.
Okay? In Python, a dictionary is, this would be the key, a colon, and then the value, and then a comma, and then the next key, colon, and the next value. In High, it's minimalist, right? So it's curly braces without the sharp sign. So, and then a key, and then a space, and then a value, and then at least 2 spaces, and then the next key and the next value, right? And I put in some extra ones in there because when I exported this org mode doc to Markdown, it helpfully removed the double space. Okay, so a fraction is a type in Python with a couple of coordinates, and in High, like in Common Lisp, you can just go ahead and put a slash mark in there, right? And High actually reads in 1/3 as a fraction. Okay, any more questions? Okay. Classes can be defined.
Actually, so, I do have a question for functions.
Sure.
Functions with parameters. Does High allow like named parameters?
Yeah. Yes.
Okay.
Yes, it does. Actually, that's a good point. I should put that in here. Okay. Bang bang. Show named. Yes, it does.
And what about optional parameters? I guess it wouldn't because I don't think Python allows optional parameters. So
I think it handles it with keyword args.
Oh,
and
got it.
Args and keyword args.
Okay. Cool. All right. Nice.
Okay. Then now more interesting definitions. If we wanted to define a class for some reason called Big Sur, this would be the standard way to do it. You know, the very boilerplate def class in Python. So call def class, pass it a symbol name or symbol to use to represent the class, then a list of parameters. Well, actually, this would be the inheritance, right? Is it a subclass of some other class? So then the init, the dunder init, and it takes in some parameter x with the call to Big Sur, and then sets the self.x to whatever you pass it in, right? And then a simple something to do with the object is get the value of x from it, right? So parameter self and return self.x. So in High, seem to have removed the code. Do I have it in there? I've removed it. I'll have to put that in the code later on. That's no good at all. This is a miss on my part. I could go look in High's online docs. Let's see. We can show real quick some decent, very pretty good, really pretty good documentation here for High. I have a link to this at the end of my text. Okay, cool. What if I stop that? Okay. Is this making sense? I don't see an init. It's no good. All right, I don't have a good example. Could try it, but let's not waste time on that right now. But the way if we had bar defined, stupid big if, but if we had the class Big Sur defined in High, then we could call it with, where do I have that? Big Sur 17, and then that would create an object named bar of class big sewer with the x attribute being set to 17. Then how to access these? I guess I should figure this out. Oh, wait a minute, I do have it in Hyer right there. Shoot. It was so similar to Python, I didn't even see it. Okay, so let's look at this. So we're doing defn, so we're defining a function called dunder init self.x set v thing. So set v is how to set a value, and we're going to set which thing to which value. So now, if I instantiate the class big sewer and name assign that to the symbol bar, then it will work as expected. So. Now there's a number of ways to get information back out of that object. The very simple one is just to do bar.x, which gives us 17, right? You can also do bar. So here we didn't. If we do this, we don't need to put it in parentheses, right? Bar.x is 17. So I could also say, okay, bar.get -x. Better do it in some case. Bar.get -x 17. We can also, Python, or in High, we can say dot on bar x. Gosh.
So
17.
The dot is almost it's trying to give you dot notation in Lisp.
Yeah, they want to. Well, that basically, they view it as basically in Python, you're going to do a dot on an object,
Okay,
right?
got
And
it.
stuff that comes after the dot, what you want back.
And the first argument to that dot is the object instance, right?
In this particular syntax, so there's 4 ways to get the value 17, right? There's just straight on the object, give me its x attribute. Here we say, okay, on bar run the method getX, or the function getX, right? Which we defined up here as simply given that, right? But that could be any, of course, that could be a complicated function, right? And then we can also do, okay, dot on bar. So here is another way of looking at it, like it's not really a function, it's just give me the attribute x on bar, right? And then eventually, there's also, now we can say dot get x, dot get -x, which is now function in the object on bar, right? So if we do that, dot get -x, gosh, dot get -x on bar. Right. Okay, so that's 4 ways to do that. So these can be used, the ones that can be used if the identity of the form to be queried will be the result of a function, then use .getX on it, right? Meaning this, right? So say that I don't know, in my code, I don't know exactly what object I'm going to get, right? I can't specify it by its actual name, but I can, by calling some other function, get back an object, right? So this syntax will work, dot, and then this evaluates to an object, and then give me the x on it. Or we can do dot get x on some function, which will give me back some object on that. Right? So that's 2 ways to do it. If to get an actual object to operate on, you need to evaluate a function, right? Does that make sense?
Yes, that makes sense. Thanks.
Okay. All right, so functions, named functions. We did this. Okay, I'm repeating myself, but in Python, we have that. In I've already defined both of those. So now I have a function that is going to use, I've already done that too.
Keep going.
Okay.
This is all repeat stuff.
Okay, so anonymous functions in Hyer can be arbitrarily complex, unlike the lambdas in Python, right? So because it's code that's going to be evaluated like Lisp, and then it's going to compile down to first the Hyer AST and then over to Python AST. So for that, this is simply, instead of lambda, they just say fn for function, right? So we do this. Go here. Gosh. Okay. So we've made an anonymous function fn that has one parameter x, and then we'll evaluate plus 10 on x, and then we pass it in. We're mapping this anonymous function across this iterable 1, 2, 3, right? Then in Python and Hyer, in order to get an actual list back on that, map will return a map object, which is iterable, but hasn't been iterated yet, right? So in order to actually get back a list, we have to call list on the iterable. Does that make sense?
Yeah, but so this single parameter function is pretty typical. Can you do does map allow you to pass in like multiple lists, and you can create like a function of 2 parameters that take one element from each list? Do you know?
Let's try it.
So I'm thinking of something like that would at the end create a primitive zip.
Right.
Yeah.
Well, you can do zip in here.
I know. Why. But you close the anonymous function first, and then pass 2 lists.
Right, so that's right.
Yeah, you have
so
2
the anonymous functions defined.
Yeah, so pass 1, 2, 3, 4, 5, 6. Well, no, 1, 2, 3, and then 4, 5, 6. Or 1, 2, 3. That's fine.
Whatever.
Yeah.
Okay. I just mentioned that, so let's just go ahead and see what we get back if we run list on that. And I still need to train my fingers.
Boom. Nice. Okay. This shows that you can actually do a lot. Oh, that's crazy. That's awesome. That's good. All right. That's consistent.
Okay. So let me see. Set foo to that. Foo is true. Okay, bar to 0. Now, Hyer uses Python's sense of truthy and falsy, right? So 0 is falsy. So if I run this, if bar, which is 0, but is falsy, the first one should not be evaluated, right? Good, right? Whereas, okay, so foo, so bar got checked, right? And bar was 0, which in Python is falsy, so this would fail, right? Of course, in Lisp, 0 itself is not nil, so that would have been, first one would have been evaluated in return. So then foo got evaluated, foo was set to true, so second one gets passed. So if I
I
wanted
have
to
a question
say,
with this syntax. In Lisp, at least in Common Lisp, I'm almost certain in Scheme as well, and its variants, if takes in a condition, a truth form, and then a false form. Here, it looks like if is being evaluated like a cond. It's checking the first condition, and if it's true, it'll execute. Okay.
Yeah, that's exactly right. It is kind of like cond or switch, right?
Yeah. Okay.
So the first one, it's going to look for the first of, you can think of these kind of like dotted pairs, right? So it's going to evaluate the one on the left, and if it evaluates the truthy, it evaluates the one on the right. Otherwise, it fails over to, in this case, foo, right?
So then,
And
what
it evaluates foo.
Sorry to interrupt. Just then, what if you wanted an if else, like an if else in High? Is there like a default case in this if form where you could just not specify a condition saying nothing is valid?
Well, I guess if you wanted, you can put in any value you want here that is not falsy, right?
Yeah, that's what I was thinking.
So you could, if you wanted to, you could just set v to otherwise, right?
Yeah.
You just do set v otherwise to true, right?
Okay. But
I mean, there may be a way. I don't remember that.
But the form itself doesn't actually. You don't think that the if form itself, as it stands, provides you anything syntactically to actually do that.
Let's read further because I remember something about this. If no test is truthy, then none is returned. However, also available are if not, if star, which is just only one conditional test success pair, right? Which is what if not with a star is built out of, right? Or elif, which is Lispy if, right? In that case, right? Yeah. So it's Lispy if. So false is only on none, which is like in Common Lisp, only on nil, right? So even the value false is truthy here, right? That's kind of interesting. And then Lispy not if, right? Okay, con creates nested if expressions for each condition. If it's true, the associated form is evaluated, and if it's false, the else action is to move to the next test. Okay, short circuits and no further evaluation is done. And so, this is just my note to myself. A straightforward macro here would be to make case, right? But I haven't done that. So here's an example.
Oh, wow. Okay, so you also have cond, but if, as it stands, acts like cond in a lot of cases.
Yeah. Mm-hmm.
Okay, so, very nice.
That's an interesting point. So why do they have both? Because they seem to operate kind of the same.
Okay.
Okay, so in this case, if we so in the first one we're evaluating a symbol, right? Some value, something that has a value itself. And here we're evaluating an expression, right? So is 100 less than 1? No. So we would never get to print not here. Is 100 less than 200? Yes, we'll print here, right? And then even though this one is true, 100 is less than 500, we never get there because the con short circuits as soon as it finds something that works, right?
Right, so that makes sense.
What evaluated out was true, right?
Mm-hmm. Mm-hmm.
Okay, so code blocks. Do is for executing a series of things, right? So if we have one of these conditions that's true, and we need to do some complicated stuff that we haven't wrapped up into a single function, then we can just, in Common Lisp, it's the progn, right? Progn. So in High, it's called do, right? And that's, of course, what I just said. It's handy for conditionals if you have to trigger a series of expressions to be evaluated. So if foo, then do print 100, print 200. If we fail past this, then it takes the second one, right? if does take. It is if, and then the, what do you call it? What is it? So this is our predicate, and this is the what to do if it's true, and this is what to do if it's false. So if we evaluate this, we should print 100 and 200, right?
Right.
So let me get a little more real estate. If I evaluate this, yeah, 100, 200. Okay, so that shows that it's the classic if, and then first and second. But then the do lets us wrap up a series of things to do. And of course, this could be arbitrarily complex. So the let form, like we'd expect, it creates a scope for bindings, and then bindings made inside the let shadow any external binding, and then they disappear when we leave the lexical scope of the let, right? That makes sense?
Yep.
I'm pretty sure you get that, right? Alec, do you get that? Okay. Now, one thing to be careful of is that unlike common Lisp,
sorry, I'm just following along.
The let bindings. Okay, cool. So, whereas in common Lisp, let, just plain let with no star would evaluate everything kind of simultaneously, or they, given the form of values, go through the entire list of bindings and not take into consideration my new binding for foo when I come up with the value to bind to ball, right? So in this case, and this is some unfortunate formatting syntax. So this should kind of look like this. Let in high binds symbol value pairs serially like let star in common Lisp.
That's actually very similar to what Clojure does too. Clojure does it doesn't have a let star, it just does a let, and it serially evaluates everything in sequence. So I think
and so the high guys make a point out of wanting to be one of their guiding principles is be Clojure-y, right?
Right. So this is more in line with Clojure semantics than common Lisp semantics is what I'm kind of at least what I'm getting at from this demonstration, which is fine. I mean, it makes sense, but because Clojure is a more familiar Lisp to a lot of folks.
Right, and so that is actually one of their kind of design considerations as they've been building high. To be Clojure-y, right? And they document that on their website. Okay, so in the current version of High, let is actually a contributed module, so it needs to be called in. We need to require it, right? So we do it this way: require high.contrib walk. Right, walk is kind of a package, and then inside that package we want to get let, right?
So it's not part of the standard library, that let.
That's correct.
Okay.
Not yet, right? Of course, they're working toward that, but they haven't. So this is an example. So we do let foo is going to be 5 and bar is going to be 7, and we print those two. Then we're going to get what? Plus foo is 5, so we should get 105 out of here, right? Okay. So now we're outside the scope. So if I say now print foo, right? Print foo 3, right? And then that will, of course, work in code that you write inside of functions or whatever. It's just this let right here starts a lexical scope, and as soon as we get to the end of it, the shadowing bindings go away. Right? So I guess we could try this, right? Let me see. I don't think bar. That's set bar to anything. Bar 0. Okay, so let's say Baz, right? And make sure Baz isn't anything right now. Okay, cool. So let's see what happens if I do this. Baz to 7 and plus Baz to 100, right? Okay, and now if I say, hey, what's Baz? So what are you talking about? Okay, cool. Does that make sense?
Yes. Although I noticed that you're not using foo in that example, so foo is just not, it's just an unused variable in that form.
Yeah, that's right.
Okay.
Right. I just wanted to show that inside the lexical scope, one of those things does have a value. And in the case of foo, we had set it outside of that lexical scope to 3, and it came back to 3. Whereas Baz didn't even exist in the outer scope, right? And then we temporarily set it to something, could make use of it, and then when we exited the let, it went back to undefined. Right?
Question.
That was the point of it.
Does High have a notion of special variables, like in common Lisp?
Yes, it does. I haven't looked deep in that.
Okay.
Okay, describe what you mean by special.
Special variables, like in common Lisp, you have the ability with the use of def parameter to create, or def var, to create variables that have a slot in memory, but don't have a binding, right. And you can bind them inside of a let form, but to different values, which gives you the ability to do things like, say, for example, create thread local storage and this sort of thing. The closest analogy that I could think of them is like environment variables. All right. Does Pi provide something similar to that effect?
I understand what you're saying. I have not studied that in High.
Okay.
So my guess is this. Okay, the reason that this thing is called High is not because they wanted to make jokes about smoking weed, right? It actually comes from the word hymenoptera, right? Hymenoptera, which is a Greek word, and that's for the class of insects like ants and bees, right? And the reason that that got chosen early on was because the guy that got the idea at first, and I have links to his videos, or at least one of his videos down below, is very interested in distributed computing, right? So if we're going to need something like threads and a type of variable that we can use with threads, then it's probably addressed. Not addressed in this talk.
Got it. Okay.
But that's the kind of thing that the guy that started High was actually interested in doing as an undergrad and then later on, right? So I would guess that.
So I'm jumping ahead. My apologies.
I don't know. No, it's totally okay. It's a very interesting question, and that's my take would be if it's not in there, they've thought about it a lot.
Okay. Cool. All right.
All right. So what do we do here? Using Python in High, right? So very similar to imports in Python, and this is the syntax for it. So we're going to import numpy as np, and pandas as pd, and math as torture, right? So if I do that. Now, if I want to call something from math, like cosine, then I use the name that I imported it as, dot, inside the package, and then call it on something. So, right? Makes sense? That's cool. An alternative syntax is, again, doing the dot cosine. So calling dot, and then on torture, looking for cosine, and then apply that to 2, right? Same thing. So we can also import, if we want, just individual functions. So I better do this twice, right? Is it gonna work? Where is that? Cool. So I'm gonna have to do this twice. Huh? What do I do here? Down here, Z, and there, and there. Okay, cool. Now I can just call it directly, right? I don't have to specify basically the package name, right? We've imported it under its own name. Then
is that a different sorry, this question, is that import different than the require that you did before? Like you had
require is we use with macros, right? Because we can't say import if we're going to import a macro, because import means something in Python.
Got it. So okay. Just wanted to know
especially if it's something with macro. I'm sorry, I should have called that out.
I have a quick question also. So with the importing of a specific function, like import math cosine, if we know other functions within or the methods within math, we list them out as a list.
Mm-hmm. Let's try it.
We don't need a comma or anything like that. So that's still
no.
Okay.
Let's try. I think it's going to work, but let's try it out.
I would assume that it would work too.
In Bark, right? Yeah. Print. Oh gosh. By the way, this is not have anything to do with Lisp or High. But don't you think by this time we should actually have a key that just does copy, right? Instead of Control C. Okay, so print sign of 2. We think that got imported. Yep. Okay. Cool, Alex. Good, Alec, good question, man. Thank you. So cos2 does that. Okay, how do we do high in Python? So let's say that, first of all, we do need to import high. Right? And then we have some module that we want to import. So we can import that module as, and then we give the name, right? So if we have some function foo that's defined in the module myHy module.high, then I can say, okay, zog equals, this should be baz. Baz.high, all right? So then we can say zog equals baz.foo bar. Oh, I'm sorry, wait a minute, this is wrong. I had this. This is correct. Okay, because I've imported my module, but I've given it the name baz. Right? So some function foo inside the code called myHy module, right? But I've given that the code, once it's pulled into Python, it's called baz. So foo from baz on bar equals zog. Does that make sense?
Foo, baz.foo bar.
The important thing here is that this is no different than import numpy as np, right? So we don't want to use the name numpy. We would never do this, right? Foo equals numpy dot something, right? Array on 1, 2, 3. Because when we imported numpy, we said you're going to call that np, right?
Right.
So
you created an alias.
Exactly the same way. It's not at all different, right? So we've got our code in something called myHy module.hy, right? And then we're going to evaluate that, which will give us some functions, and we're going to call that space baz. And then from baz, we're going to call foo on bar and return and assign that to the symbol zog. Straightforward. very, very Pythonic, right? Well, this is Python. But the important thing here is if you have .hy files and you've imported Hyer, then you can just like you would with any Python file or Python module, you can use exactly the same import functionality.
Okay, one question: how do you define your own Python module? I mean, sorry, your own Hyer module.
You define a file and call it .hy.
That's it. Okay, so it's the same semantics as Python. Okay, cool. That makes sense.
Yeah. Now the cool thing is, this. I'm sorry, Alec. You had a question?
Yeah, just to clarify a basic question. So what allows it to what allows the function to have the .hy extension? Is it because you've imported Hyer, and then so is it kind of baked into the syntax, then the Lisp syntax so that?
No, not quite. That's a great question, and it's on the edge of what I think you were getting at, Ram, too. And it's this: the Hyer module there is a particular, what do they call them in Python world, like as a pip, right? Wait a minute, path, right? There's a specific one that allows control of the import mechanism. And these guys, the guys that built Hyer, did a very slick job of changing the stock Python import functionality so that when it's looking for, whereas Python would look for a .py file, once you've imported Hyer, that's changed a little bit. So it will find .py files, but it will also find .hy files. And I think it might even look for hy files kind of first, which is pretty slick. Because Hyer also, if you import Hyer, it also controls the evaluation of the Hyer code, right? And this is why, as soon as stuff is imported in Python, after this line right here, Python doesn't know it's not Python, right? It's going through basically exactly the same from your Python code's perspective. Once you've imported something, instead of going and getting some Python code and taking it down to the Python AST and then importing that, it's done exactly the same thing, but it's done it from a Hyer file and used the Hyer module to evaluate it, build a Hyer AST, and then translate that to a Python AST. So once, basically, Python never knows, right? And there's some, if you go watch their videos, it's so deep that even the Python debugger isn't fooled, or is fooled, or plays along, right? So you can actually go and put debugging statements in Python code to debug Hyer, stuff from Hyer, and the debugger will pop up and it will show you Lisp code, right? It won't be confused at all. It'll be like, yeah, of course, pretty slick. Okay, so macros, everyone's favorite. I love macros. They're my favorite part of Lisp, and they allow the full power of a Lisp language to be used at compile time, to build code to be executed at runtime, right? So we don't have enough minutes to talk about macros. But two things that I think would be immediately useful are extension of the syntax of a language, right? And so an example of that is the infamous walrus operator that got added to Python 3.8, which is a lot like equals, but also returns the value, right? Whereas equals does not in Python. And I guess this is kind of confusing. So that could be done dead simple. I mean, it's really almost boring. So in Python, if I say foo equals 3, none gets returned, right? But once you implement in Python 3.8 and later, using the walrus operator, we'll set foo to 3 and also return the value 3, right? So there was great controversy around whether or not, is this Pythonic or not, but it ended up getting included. And this is how it would be done in High, right? We define a macro called walrus, and it will take a symbol and some value, and this is the macro syntax, or the macro type characters that are important. So backtick is just the same as backtick in Common Lisp. And what backtick does, so normal quote would absolutely set in stone everything between those two parentheses. They would not be evaluated at all. It would be pulled in as text to be used for code to operate on during the macro expansion phase of life, right? Backtick, on the other hand, is called quasi-quote, which means pretty much quote unless I tell you otherwise, right? So in this case, the symbol set v would be pulled in, and then this tilde it means, okay, go ahead and turn off the quoting for the extent of that thing, I guess, expression. So in this case, it's just an atom, right? And then also I want you, so what this is saying is, okay, you're going to write some code, and that code is going to be set v, and then where I have tilde symbol, I want you to pull in, want to evaluate what got passed here. Not just, don't use the symbol, don't use the text sim, give me the evaluation of what got passed in via sim. And similarly, for tilde val, evaluate what got passed in via val, right? So now the statement would be something like, do I do this? Okay. The code that will be generated in the one layer of macro expansion, if I called walrus, gosh, dang it. Right? Man. Okay. Should look at stuff all the time now. Walrus 223. I'm losing it. Okay. That, according to this def macro, would get evaluated. This would become set the foo 23. Right. Now that gets, when that ends up getting evaluated kind of at runtime, foo now equals 23. And then walrus will return this, right? That makes sense? Anyway, walrus now is a Lisp operator or function that will take some symbol, give it a value, and also, unlike normal Python, return the value of that symbol, right? Which could be used if you have some complicated thing where you're going to do an assignment in the middle of a function and you need to make use of the assignment you just made, right? Anyway, maybe I can't explain that very well.
So you can think of a macro as kind of like a template of code that's going to be generated at runtime. The difference between quote and quasi-quote is quote doesn't allow you to evaluate a particular expression when you actually quote that between two parentheses or even a particular variable. Let's say that you had a variable called foo, and you quoted foo. If you defined foo as, say, 3, let's do def foo 3 or whatever, you'll see that the REPL did not actually complain about that that coup was not defined. Now, since if he just gets rid of the quote, just to show this to you, and coup is not defined, you just show that example, and get rid of the parentheses too as well, or it doesn't matter. You'll notice that the REPL will automatically throw an error here, because what it's doing is the way Lisps work is they do a lookup at evaluation time to see if a particular name is defined, to determine whether or not it's a function call or a variable, and then at that time they'll retrieve it and do the evaluation. Where macros come in is, and their uses is oftentimes, is there's a particular operator or set of operators that may not exist in an existing language, which is one. Or there's a domain that specifies a set of operators that you may want to use in your program because that is a more consistent way of expressing your solution. In those cases, what you can do is if in other languages, like even in Python, you can't actually extend the language to include those operators. Macros give you the ability to extend the language to include those operators at the level at which they were native as themselves. And what that means is they can transform into proper Lisp code. The quasi-quote operator there that Judd is showing you, which is similar in both Common Lisp as well as Clojure, is essentially allowing you to define a template, okay, if you will, a template of a particular piece of code that at eval time, if you just run it on the REPL as is, it will be equivalent to a normal quote. But if you use a def macro in, say, another higher level form, it will evaluate it by looking for those tilde symbols, reaching out into the REPL, figuring out to see if those symbols are available, those are valid Lisp expressions, evaluate them, and then inject them into the actual form that you're actually evaluating. So if you take the example that Judd wrote with set foo, let's say that he used foo in this case, what it did was with that tilde foo is it reached out into high space saying, hey, is foo defined? If it is, okay, I'm unquoted, evaluate me, tell me what my result is, and then stick my result into this form. And that's why in this example at the REPL, that backquote tilde foo evaluates to 3. Is there a macro expand function at all in?
There is.
Yeah, I think that's probably the best way to show.
So
yeah, moo is not defined. That's because you didn't.
That's not good.
You're supposed to set v. I don't think defines your variable, dude. Does it? Yeah, but it's not injecting moo into there. It's injecting the result of moo. That tilde symb that you have there, okay, that unquote, is saying I don't want. I don't want. Maybe. You could try that. I don't think it.
I don't think it's gonna work.
I don't think. I don't because it's scoped. I don't think it's gonna work. But you could try it. And type in moo. There you go. So the reason why I wasn't sure
that didn't work.
is
I wanted 19.
What? Oh, it's not 19. That's right.
I wanted moo to get set to 19, right?
Right, right. So since you defined moo earlier, if you do tilde symb, it will work. So what you have to do is this is where gensim comes into play. You need to create a symbol that represents the pointer location of sim, and then inject that gen sim into the set v, and then it will work. Do you have gen sim in High?
No.
Yeah, I don't think you could define it this way. Yeah,
I think we do actually. Hold on.
Type in gen sim.
Okay. Not working as I want it to. So this is the beat part of the show.
Yep, it's always.
Okay, I'm looking up generic symbols.
So this is going into macrology that I think would be fairly there you go. You do have gensim. Nice. Yeah, I think if we do let gensim be just sim, and then do tilde that guy, it should work. At least I think so. I don't know. You got to try it out.
Okay. Okay.
Yeah, you can move on, and we can return to that example later on. Yeah.
Okay. Well, this seemed to work earlier. And this is stuff I haven't written yet. Okay, so now we can talk about functionalism. Okay, so High is really a Lisp, and it's a Lisp 1, which just means that there's one namespace. There's no separate namespace for functions and other objects, and it can be used in obviously a functional style. So these are the three. Map applies one function to each element of some iterable data structure. So if I were to say, if I have some function called foo_fun, right? Now I can say foo_fun 44. Okay. Now this code right here just maps that function across some iterable of x's, right? So if I say, okay, foo map 1, 2, 3, 4. Oh, well, okay. Right. So I think that's straightforward. It's just taking the previously defined function and map that function across some iterable, in this case a list, and then it returns a map object, right, which hasn't been iterated. Or, right, if we want to actually get our list back out, we can just call list on it. No big deal. So similarly, just okay. All right, so then filter applies a predicate to some list of some iterable, and then either includes or excludes the element from the list into the resulting output. So let's see. I have some predicate function fizzy, right? This is going to determine whether or not some number is fizzy or not. Fizzy being from FizzBuzz is the modulo of of 3, 0. So I can say fizzy 3. Oh, wait a minute, why not? Oh, fizzy question mark. Okay, so that's a predicate. It's either going to give us back true or false. So then fizzies would be applying that predicate to some list. So we apply filter using the predicate fizzies onto some list of x's, and then get that back. So now I can say that our fizzies, I can say 2, 3, 6, 7, 8, 9. It gives me back the ones that are fizzy, meaning divisible by 3 with no remainder. So that gives. So we've used map, and we've used filter, and then reduce can be used on something to reduce or to fold. So if I wanted to get the total of all the fizzy numbers, then I can run give me the fizziness of some list 3, 4, 6, 7, 8, 9, right? Why? Can only this should have worked. Oh, because I didn't include the default, what to start it with. What did I do wrong here? That's not. Should have worked the first time, right? Why did this not work for me?
It's just that's because fizziness takes one positional argument, but 2 were given.
Okay, I think.
Yeah, you passed in 2 arguments, dude, to fizziness. You passed in 2, 3, 4, and yeah, if you hit enter there, that should work.
Yeah. Can only concatenate list, not int to list. What have I done wrong here? Maybe this is it. Huh?
Oh, reduce your initial argument is an empty list instead of 0. Fizzies is a list. So when you do a reduction there, yeah, the first argument should be, that's a sum, so that's 0. So I think it's you could do it that way too, or it'll take in the initial argument. But try that.
Try it. Did I evaluate that?
No, you didn't actually define you didn't evaluate the function. Hit enter. Now you evaluated it. There you go.
Okay. Now I've got the total fizziness of this list, which is 3 plus 6 is 9, plus another 9 is 18, right? So that's the big 3, map, filter, and reduce. And so you can write very Lispy code in your Hyer files and make use of them in Python files. So this is what we've done, right? We've talked about what Hyer is, which is a Lispy syntax that boils down to Python's AST. Why coders might want to use Hyer. Lispers might want to make use of the Python ecosystem. Pythonistas might want to get more familiar with Lispy stuff using code that they already have. And then we've talked about an overview of how Hyer works. I don't have any pictures for that, but basically Hyer code boils down to first the Hyer AST, and then that gets translated over to a Python AST, and then from that point forward, the Python half of the world doesn't know that it wasn't Python to begin with. And then how to install it, easy. How to use Hyer from a REPL, talk about data types. We walked through some data types, structures, classes. We did a little teeny bit about macros. There's a lot more there. And we talked about functional programming in Hyer. And I have not yet demonstrated the interoperability between Hyer and Python code. And I think I'll leave that for a later show. But there's plenty of stuff that we can look at later. So in general, further, Hyer's been around since 2012 and has a lot more that can be demonstrated in the talk. It has something called the threader macro, which I think is another clojure type thing, which looks like this. And that takes a series of expressions and then evaluates the first and then feeds the result of that evaluation as the first parameter to the next. So it's a lot like partial application. But, and unlike making just plain, instead of currying functions where, the first function can take in some number of parameters, but must generate one output that then is taken by the next thing in the curry. And then eventually at the very end, it could generate more than one output. This evaluates the first and then passes that as the first parameter to some next thing, right? And it's undefined what other parameters there are and where they might come from. And then threader with two greater thans feeds the output of each as the last parameter value to the next. And then tag macros are, I guess they're kind of like reader macros in Common Lisp. Basically, it's a character that can explode out to some syntactic sugar around things that follow. Again, I think that we can talk about that later. And you can use Hyer as Unicode friendly. So you can use any of the however million characters you want to make your tag macro. So we also didn't talk about anaphoric macros. So here's some resources. Basics are here at hylang.org. PyPy is there. If you want to look at the source code, it's here. There's a list, Hylang discuss. Stack Overflow, if you use the Hyer tag, you'll get there. And then this is interesting. So this is some Hyer code that's contributed to get it even closer to Common Lisp. This guy over here, Richter, has contributed some cool stuff to make it so you can write Common Lisp, almost Common Lisp in Hyer. And there's a bunch of videos you can take a look at. Chris McCormick from ChiPy, or Chicago Python, gave a talk in 2016. Paul Tagliamonte is the guy that started all this mess, who wanted to study distributed computing, right? So he gives a good talk on that. It's available here. Oh, wait a minute. I'm wrong. ChiPy is here, Christopher Weber. And then a book, Mark Watson wrote a book talking about using the Hyer programming language. In this case, it's pretty much wrapping Python in Hyer syntax. I haven't seen a really deep example of using macros, which I was looking for and didn't see, but I'm really happy to have read his book. My points of contact, if you happen to be on Urbit yet, there's my planet's name. I have an email address, gptix@protonmail, gptix on Twitter, and then here's where the code as of 2 hours ago is located. Okay? How's that for everyone?
Nice.
You okay with that, Alan? What do you think, Rom?
It's good. I mean, I have a few other questions, but I'll take them offline just because I think a couple of them are more involved than the time that we have here. But thank you, Judd, for presenting this. To those of you in YouTube land, I appreciate your time for joining us today. Stay tuned for more talks like this on the Atlanta Functional Programming Meetup. Please subscribe to our meetup page. Subscribe to the YouTube channel if someone gave you this link, if you can. We have weekly meetings on Common Lisp every Saturday from 1:30 to 3 p.m. Eastern Standard Time. Well, Eastern Time now. I think Daylight Savings has got kicked in. Anyway, and we are always in the mood for folks who are willing to give us talks. If you have a talk topic related to functional programming, whether it be architecture, a different programming language, or what have you, feel free to contact me or Judd. We both hang out on Tech 404, as well as that's a Slack server, as well as I usually hang out on the functional programming Slack channel in the Lisp chat room, and you guys can contact me there if you guys have any other questions. So until next time, I appreciate all of you joining us. I'll see you guys later.
Okay, thank you very much, Rom, and thanks, Alec, and other YouTubers.